So perfect. We'll just jump right in. So my name is George Karras. I'm the founder and president of Prasino Engineering. We've been in business since 2013. Some cool achievements. I just always like to start that is an achievement of mine that I'm pretty proud of. I built 5 factories internationally from the ground up, from determining the location to all the way to commencing and operating the factory. Alan, you want to introduce yourself?
Sure. My name is Alan May. I'm a mechanic engineer by training, and I have been working on a lot of energy models. I'm also a IECC certified commercial energy plan examiner. I am a consultant to ASHRAE SSPC 90.1, which develops ASHRAE 90.1, and I'm also a voting member of IECC modeling subgroup.
Awesome. So the learning objectives from this presentation, really there's 4 learning objectives that we're going to go through today. So we're going to compare the codes. One of the things that you're probably noticing even here within the decoding is really identifying the differences between IECC 2024 and ASHRAE 90.1 2022. And we're going to even get into the context of why even ASHRAE 90.1 2022 is coming up, because obviously Illinois has adopted the 2024 IECC. So why is ASHRAE even coming into this conversation? So we'll get into that a little bit here. We're going to go into selecting compliance paths. There's different methods to go into the prescriptive versus performance path, and various options that you have as an architect to choose the appropriate path for your building. And then applying those provisions, right, the 2024 and 2022 ASHRAE provisions and how they affect your projects. We're going to do a little bit of a side-by-side comparison of those. And lastly, executing the commissioning role and describing commissioning. A lot of people obviously have been a part of probably commissioning from other projects, but it's been elaborated within the 2024 IECC. So we really want to touch on those points and bring that to head for everybody. Let's see. Okay, so the fundamentals of so what's the energy codes and why do they matter? So the energy codes, you got to remember, these were Illinois State Board of Education adopted IECC January 1st of 2025. The state of Illinois adopted 2024 IECC November 30th of 2025. Something unique there that hasn't really happened before is that the Illinois State Board of Education adopted 2024 IECC before the state of Illinois did. So that's something that's unique to this last year, but something that everyone's been navigating and has given us a lot of comfort into the code because schools have been actually at it since January 1st of 2025. So minimum standards, IECC and ASHRAE 90.1 set the minimum efficiency requirements for envelope, mechanical, electrical, renewable, and the service water systems. So most states obviously require some sort of energy compliance to obtain a building permit. So that's why this is a legally required component. You as architects on this call, you're responsible obviously for demonstrating compliance, and understanding code is essential. So we're here to help navigate that and provide some good context for you. Just something so everybody is aware, IECC publishes the IECC every 3 years, and ASHRAE 90.1 follows a similar cycle. They lag about, well, I think 2 years behind each other, and states typically lag 2 to 4 years in adopting these codes. For instance, just now Illinois adopted 2024 IECC, and we're 2026. The keyboard is not liking it. There we go. So differences between 2024 and ASHRAE 90.1. One thing to keep in mind is when you're looking at the code is you really cannot, you cannot simply mix and match. You're either choosing one path of compliance. And why is this ASHRAE keep coming up, right? So per 2024 IECC section C401.2.2, ASHRAE 90.1 2022 may be used for commercial buildings if followed entirely. So that's a key component here that we're going to really discuss in this presentation. And subsequent slides, you're actually going to see IECC and ASHRAE flip in columns. Our recommendation, and you're going to see that throughout this presentation, is to follow ASHRAE 90.1 2022 2022 over IECC 2024. There's various nuances to that recommendations, and you'll see that within the presentation why. Compliance check wise, you either have two options, right? It's really the prescriptive or the performance path, and that applies to both. And we'll describe kind of what that is here in a sec. But ultimately, if I'm going to tell you what prescriptive path is and give you an analogy, it's turn-by-turn directions to arrive to a destination, where performance path is getting to a destination any route you choose. That gives you a little bit of good context of those two terms and how it plays into the code. So once again, your compliance path options, you have two paths within the code. You can follow 2024 IECC or ASHRAE 90.1. And once again, that section is there for reference. We really want to drive this home because there's a lot of confusion within the industry about this. Alan, you want to take this slide?
Of course. So both IECC and ASHRAE 90.1, they cover different scopes, new construction and existing buildings. 90.1 does cover existing buildings, and then in existing buildings, you have addition, alteration, and change of occupancy and repairs. So we ranked the stringency levels based on different scopes here. Obviously, if you have a new construction, it's the most stringent. You basically have to apply to every applicable provision. But if it's addition is slightly less stringent, in some cases, it allows you to comply, the addition plus existing building as a whole to comply. And for alterations, generally, we have a term, if you touch it, you fix it. If you don't touch it, you don't have to fix it. Right? So if you touch anything, you basically have to bring them up to code. And change of occupancy is a little tricky there because let's say if you change a warehouse to an office building, right, you change the occupancy type and increase the energy use. In that case, you have to comply as even new construction. But obviously, there are some exemptions, like if you use modeling, the modeling pass is less stringent. Same thing for comp checks. And repairs basically exempt you from most of the provisions. That's why it's the least stringent scope. Next slide. There are generally three ways to comply. This is true for both IECC and 90.1. They have most people are very familiar, very familiar with prescriptive path. Basically, you just follow whatever the code says. IECC says R30 on the roof, you do R30 on the roof. R10 on the wall, you do R10 on the wall. And basically, very, very straightforward, very clear. Option number two is to do trade-off. This trade-off is within envelope or mechanical. So something new for envelope trade-off, it's very straightforward. You run that in comp check, right? In IECC, it's called component performance path. Basically, it's called total UA, U times A of all the components combined, and then you compare the designed UA versus the baseline UA. In 90.1, it's a little bit different. It's called Appendix C, envelope trade-off. It's a simulation done in comp check. In this code cycle, they introduced something called TSPR, total system performance ratio, for the mechanical compliance path. Basically, similar concept. You can trade off within mechanical. And then option number three, a lot of you, I believe a lot of you, I see a lot of familiar names here. A lot of you are very familiar with the performance path. Both IECC and 90.1, they have a performance path. In IECC is called simulated building performance. And in ASHRAE, they have two performance paths. One is called energy cost budget method. The other one is called Appendix G, performance rating method. We'll be talking about those. In every code cycle since IECC 2009, I typically recommend a preferred path. And in this code cycle, I recommend ASHRAE 90.1 2022. And if you have to pick between performance pass and prescriptive pass, I would recommend the performance pass and follow energy cost budget method. It's one-to-one and a system-to-system comparison that will give design teams the most flexibility. I'll tell you why. George, I think this is yours.
Sure, I'll get so yeah, thermal bridging. We'll get into a little bit more detail on the thermal bridging here in a sec, but ultimately it's prescriptively required within ASHRAE and within IECC. We'll give you some details here in a couple slides about thermal bridging and ways to mitigate it and points where we typically see the issues. Envelope backstopping. This is probably the only location where ASHRAE is more stringent than IECC. ASHRAE does have limits on how far you can deviate from the performance pass, and there is backstopping within ASHRAE where IECC doesn't mention this at all. The air leakage test, this isn't something new to the code. It has been around, if anyone's done residential, building pressure testing has been around for quite some time within IECC. The biggest differences here is that now the code does have specific requirements that have to be followed and square footages, but beyond that, it's also mandatory. So I'm going to go to the next slide. It's a little easier to read. So we gave those code sections there. So within IECC, all buildings, testing is mandatory for commercial buildings now. The maximum leakage that's allowed is at 0.35 CFM per square foot at 75 pascals. There are exceptions within there for construction verification when testing is not feasible, or other exceptions apply. Where ASHRAE 90.1 varies on where it's required. So it's mandatory for buildings less than 10,000 square feet conditioned area. Buildings greater than 10,000 square feet, you can either do an air leakage test or a design construction verification. The threshold's the same. What does this all mean, right? So, if you have a large facility, let's say a warehouse, a million square feet, let's be realistic, we're not going to be able to pressurize that building. So that's where you're doing that third party review of that envelope. And within that review, you'll look at air vapor barrier, you'll look at your insulation below grade and above grade, you'll look at your roof installation, roof insulation, those key components that are tied to the energy compliance. When people ask us often how big of a building you can typically pressurize, the equipment that you see within the photo there, you can get 3 fans within a typical doorway, and those 3 fans can pressurize up to 60,000 square feet. If you need more than that, you need to bring in additional fans and additional unit to go to another doorway. You typically can get to that about 120,000 square feet pretty easily. That's essentially 2 doorways. After that, you're getting into some pretty sophisticated equipment, and pressurizing of that large of a space becomes much more complicated. So that's why the code has that option to do design or construction verification. Alan, you want to talk about thermal bridging? You are on
Well,
mute.
sorry.
Yeah.
Of course. We in the US, we have been talking about thermal bridging for many, many years, decades. Chicago did something in the last code cycle. If you guys remember that, Chicago mandated in Chapter C6, mandated thermal bridging mitigation, balconies and parapets. Right? Basically, they were requiring mandatorily that balconies should have thermal break or continuous insulation wrap the entire balcony. Same thing for parapet. But that was Chicago specific, and it was similar in New York City. Um, it never, some of bridging requirements never got into the national model energy code and energy standard. Not anymore, not anymore. So in this code cycle, both IECC and 90.1, they introduced prescriptive thermal bridging requirements. Basically, they address several major thermal bridging conditions and that you have to mitigate. we recommend mitigating as well. So let's get started on those thermal bridging conditions. Number one is called fenestration and opaque wall intersections. Um, the Glass magazine did a great job illustrating this concept. Basically, you want the insulation line was your window assembly. Basically, you want that continuous thermal line instead of leaving a gap because that gap becomes a heat loss path. Most of the projects I worked on, the left hand side, the preferred approach is almost the common sense today. And the second thermal bridging condition we typically see is on balconies and floor deck penetrations. Basically, if you have a balcony penetrating the thermal envelope, right, that little balcony is a huge thermal bridge. It's like a thing. Um, and the third one is a cladding support. If you have a cladding support, that's like attaching something to your thermal envelope. If you don't mitigate, that can create a little heat loss path. If you want to move to the next one, parapets, very common, right? Very common thermal bridging condition there. If you don't have a continuous insulation, or if you don't have a thermal break, that little parapet becomes the heat basically find that pathway to get lost. The next one is beams and
Alan,
columns.
on the parapets, what are we seeing in the industry? The wrap?
We typically see now the mitigation. We typically see a continuous insulation, right? We typically see the continuous insulation extend all the way and wrap the parapets. And we don't typically see thermal breaks on parapets. Continuous insulation, better detailing is more cost effective. And the next one is structural beams and columns. This is called point thermal bridging. Basically, if you have beams and columns penetrating your thermal envelope, that is recommended to be addressed. And you should talk to your structural engineer. Next one.
Yeah, and just real quick to speak on the structural beams, we've been part of projects that we've seen some significant connectivity through those structural beams into the space and plenum spaces, so much so that we've seen sprinkler heads popping and various temperatures within plenum spaces where those beams are coming through from the outside. So it's significant how much cold air possibly comes in from that thermal bridging, right? Or how much space temperature varies due to that thermal bridging.
We talk about the requirements. By the way, the 90.1 has a little bit more than IECC. 90.1 has roof edge, and you also have to address any linear and point thermal bridging. They have a little equation in there. You just have to do the calculation and comply. They have a appendix A that you can go there and look at the numbers. Overall, 90.1 is slightly more stringent. And we talked about the requirements. Now let's talk about the compliance. How do we comply? Option number one, prescriptively. You can comply prescriptively. They have some mitigation strategy like being laid out in IECC and 90.1. You just follow whatever they tell you. Option number two is to use effective U value method and use ComCheck to basically, let's say if you have a wall that has a nominal U value of 0.1, meaning it's R10 nominal. But because of thermal bridging, maybe you have a floor deck penetration that you have to derate the wall based on the chi values defined in IECC and 90.1, then you derate. Basically, you have to add that chi value to your U value, and generally you would be derating it by at least 30%. So that U value of 0.1 becomes 0.13, 0.14. And then you use the 0.13, 0.14 in ComCheck calculation. Obviously, right, if you have to derate, use the effective U value, it's a lot more difficult to pass ComChecks. Option number three is to use performance paths. Again, in the performance paths, you're basically building models. you build in your proposed model, you will have to use the derated U value for your building thermal envelope if you don't mitigate those thermal bridging. And of course, it's going to make the model a little harder to pass. But again, I wanted to say this: thermal bridging, they did not make those mandatory requirements. It's still prescriptive, meaning there are multiple ways to comply. But if they made it mandatory, then you just have to comply with all the mitigations. This slide, it's not new in IECC or not new in 90.1. But we wanted to bring this up because we have seen a lot of confusions, especially in 90.1. A lot of you probably noticed that IECC and 90.1, they have something very different in terms of window to wall ratio. IECC prescriptively gives you a maximum 30% window to wall ratio. If you meet the daylight criteria, you can do 40%. 90.1 doesn't have that. It's just 40% window to wall ratio, right? That's one of the key differences. But in 90.1, they have a prescriptive provision limiting east and the west glazing area. Basically, it requires you to not have more than 25% of the total glazing area on the west and the east facade. Or, you can play with your solar heat gain coefficient. That is a prescriptive requirement, right? That can be mitigated, or that can be traded off using Appendix C simulation, which is a comp check. I have seen a lot of designers, they were like, oh, we have this provision 90.1, so we should not be using 90.1 because we cannot comply with that 25%. That's not true at all. You can even prescriptively with comp check. Next one. Well, we talk about the envelope. We spent about 20 minutes talking about envelope. Let's spend some time talking about mechanical. In every code cycle, both IECC and 90.1, they update the efficiencies, right? Same thing. They did the same thing. They also have new metrics. You probably see like SEER 2 instead of SEER 1. So those is because we have new metrics measuring the efficiencies today. And also both of them introduce something called mechanical system performance pass. It's TSPR. It's basically a mini simplifying energy model down in the DOE TSPR tool. You build a mini energy model to trade off, let's say, if you don't want an economizer, but you have a more efficient cooling system. And as long as that system can still beat the baseline with the economizer, you will still comply. That will give you more flexibility. And the lower, they made demand control ventilation more stringent and apply to more spaces. They also made economizer like threshold lower, meaning you're going to trigger economizer requirement more often now. Fault detection 90.1 is less stringent because they only require FDD on economizers, but in IECC, if the building is bigger than 100,000 square foot, you have to do fault detection for the building. It's basically like a full capacity building automation system. They also introduced something called occupy standby. This is basically a occupancy-based HVAC control. It came from Europe. Our European friends have been using this for a very long time. It's a control beyond DCV control. It's basically, we have a slide for that. We'll be talking about that. But one of the key differences here is that 90.1, in 90.1 it's prescriptive. Prescriptive meaning you can trade that off with your modeling pass, right? But IECC made it mandatory. Mandatory meaning even with the performance pass, you still have to do it. You just have to do it. And they also both have a high capacity gas boiler. If your boiler is between 1,000 to 10,000 mph, you have to do high efficiency boiler. The minimum efficiency is 90%. Very easy to do. Condensing boiler today, it's pretty much 90 to 95%. Occupy standby. what is that? Um, um, Imagine if you have a conference room and you use it 2 times a day, 2 times a day, and 1 hour per use, meaning you use it 2 hours for the entire day. For 80% of the time, you have no one there, right? No one in the conference room. So IECC 90.1, they came up with this requirement called occupy standby. If no one is in the room, no one is using it. Technically, you can set back, the temperature set point. Let's say the set point for heating is 78 Fahrenheit, and no one is there. Why would you condition it to 70 Fahrenheit? So turn it to 68 Fahrenheit. And no one is there. Why would you condition ventilate the space, right? Shut off the air. That's the intention. Basically, the intention is to go above and beyond DCV control and save energy. Again, it's prescriptive in 90.1 and it's mandatory in IECC. Next.
There are some considerations to understand about this too, is that if you are putting this within your project, there's strong consideration to be made about when those conference rooms possibly are used or when a large space is potentially used. You can imagine if all of a sudden that unit has been non-operational because either demand control ventilation plus this occupied standby mode, that air within that space will become stagnant. So that's something to consider as you're looking at these spaces. And another reason that ASHRAE lets you prescriptively um, do this, where IECC is mandating it, right? So we've had encountered situations where individuals will go into a conference room and the unit has been non-functioning for some time and setbacks have been made within the space. And then you bring 40 people into a conference room and all of a sudden that becomes very warm into that space because simply there wasn't enough time for the system to react. So something just to keep in mind as you go into the design specifically around this occupied standby mode. With that, electrical and lighting. So, interior lighting, everyone's pretty familiar that lighting has become more and more efficient. And once again, they lowered those power densities. So there is more control stringencies and the lighting power densities have decreased both on interior and exterior. Daylight harvesting. So what's daylight harvesting, right? It's light near the windows need to dim, essentially. This has been in code for quite some time, but the threshold has once again reduced to 75 watts, and it's the same for both. What this means, if you essentially have a space with a window, you most likely are going to be daylight harvesting at this point. 75 watts is 2 to 3 fixtures. Even a simple office now will have daylight harvesting. That's what we're seeing within the design. Energy monitoring. We have a whole slide on this, so I'll just jump right to that. But ultimately, what I really wanted to stress on this slide was daylight harvesting controls in IECC 2024 now trigger at half the previous threshold. So that's a significant tightening that you're going to be seeing within your design and your early design projects. Come on, slide. There we go. So energy monitoring. This is a requirement that within IECC at 10,000 square feet, you've got to have energy monitoring now within your building. And ASHRAE 90.1, it's at 25,000 square feet. What is energy monitoring? Energy monitoring is where you're actually looking at your load and where it's being utilized. You have for ASHRAE 90.1, you're doing your electrical systems and some added refrigeration. But best part about ASHRAE 90.1, you don't need the gas submetering, the non-electrical monitoring. So you don't have to do your natural gas, your fuel oil, propane, all those items that you're seeing within there. However, in IECC, you actually do have to do all those. So gas submetering is required. And within that requirement, you're now talking about total HVAC monitoring, processes, which is your kitchens, and other miscellaneous equipment now requiring gas submetering. To give you an idea, we just did a project, a municipal building, and adding this metering, just the electrical portion, was a $200,000 ad on a municipal police station. So it's a significant cost. And if you go to even the gas submetering, that adds that much more cost to your projects. So another reason that we're recommending ASHRAE. On-site renewables. This is probably the most common thing that we're talking about. And welcome to the era where your roof no longer has a job beyond just protecting your building inside. It actually has got to make money now for you, essentially. So ASHRAE 90.1, you'll notice there it says prescriptive requirement. We have confirmed this within ASHRAE various times. Alan's done a great job communicating with ASHRAE on that this is a prescriptive requirement. For IECC, it's a mandatory requirement. So even if you're doing an energy model, you're going to be doing on-site renewable. In our area, let's be honest, that means photovoltaics, and you're usually sticking those on the roof. There are some exceptions that you'll see there within ASHRAE, within 10.5.1. And if you do want to do energy modeling through ASHRAE because you can't meet your code requirements of being better than baseline, the ASHRAE threshold is less. You'll see there. So if you're doing a 450,000 square foot warehouse, you're doing about 225 kW, where that same warehouse on IECC, you'd have to do 337.5 kW. And we gave a little bit of a link there that you'll have with the presentation afterwards that gives you those resources that I mentioned that there's clarifications from ASHRAE on the on-site renewable and how you can not do that as you go that performance path. One thing I do want to bring out, and there's a link there from CBS News, and if you do some research from online, you'll see there's been significant fires associated with on-site renewables. It's not because of the on-site renewables themselves, the PV panels, it's associated with the installation. But if you are going to do on-site renewable and PVs, I strongly urge you to work with your insurance providers. FM Global does have some strong language within their literature about putting solar panels on your roof. IKEA, Amazon, even Walmart all have issues out there. I think Amazon's shut down all their buildings at this point, all their PVs. IKEA had a fire there in Joliet. I think another one 2 weeks ago in Wisconsin. It's just something to go research and make sure you have those discussions with your clients and what the risk is with those on-site renewable. My preference, put them on carports. Best situation. Alan, you want to take this one?
Of course. So this is this is something new to 90.1. It's called additional efficiency requirements, credits. It's not new in IECC. IECC has section C406 for very, very long time. In the past, basically you go on C406. If you do it prescriptively, you go on C406 and find the items, you claim points. It was generally between 10 to 20, and you meet the points, you comply. In this code cycle, IECC significantly expanded C406. It's a shopping list. It's a shopping list with about 30 plus measures. And for the first time ever, ASHRAE 90.1 took the same approach. So they introduced a new chapter, a brand new chapter in 2022. They moved the energy cost budget method from chapter 11 to chapter 12, and they inserted chapter 11, this additional efficiency requirement there. Very similar to IECC, actually, very similar. But the points a little different, but the intention and how it works are very, very similar. Basically, based on your building occupancy type, you find what are the required total points, and then you find relevant measures that you can claim points, and then you add them up. Let's say, I have a school that needs to show 50 points. Then you go to envelope and MEP measures and operational measures to find if you can meet that 50 points. If you meet it, you comply. Again, this is a prescriptive requirement. It applies to the prescriptive path. A lot of measures. So coordinations, you have to coordinate with the design team, like the entire project team, because most likely you won't comply with just architecture. You will have to talk to your MEP team as well. So this slide we'll be talking about performance path. IECC's performance path simulated building performance, and it's very things. In 2012 they introduced a 15% better than baseline. Then in 2021 they changed that 15% to 20%. And in 2024, they introduced the equation. So for most of the buildings, you have to show 25%-ish better, which is very, very difficult to meet. IECC simulated building performance paths is very similar to ASHRAE 90.1 ECB energy cost budget method. They actually copied the language many, many years ago, but they didn't update a lot of the requirement there, the process there. And today, as written, IECC C407 is very difficult to meet. ASHRAE offers two compliance paths. My favorite is energy cost budget method, and the other one is performance rating method. Most modelers are very familiar with PRM because it's very commonly used in LEED, some other certification programs. But generally, I recommend using ECB for code compliance because it's one-to-one in a system-to-system comparison. If you have an air-cooled system, your baseline is an air-cooled system. You won't be comparing air-cooled to water-cooled in the baseline. And it's not a stable baseline. There's no building performance factors. A major change in ECB in this code cycle is that ECB is linked to the energy credit. You don't have to meet the energy credit, but you just have to show some extra savings. By not doing the energy credit, you just have to show extra percentage of savings. And for most of the buildings, you have to show 5% better. And in the ECB baseline, you have PV in the baseline. In the proposed design, you can, if you don't want to do PV, you can still do that, but your baseline model does have PV. And if your proposed design can still beat that baseline with PV, you comply. Next slide. I saw a question from Jason about envelope backstop. So this is a slide where I'll be talking about backstop. So what is backstop? Backstop is basically, in the past, when you run a modeling pass, you don't, even the wall has no insulation on R0 and roof is like R20 versus the baseline R30, as long as the model passes, you pass. And we received a lot of concerns about that approach because you could literally trade off more efficient MEP system with a bad envelope, right? So in 90.1 2022, they added an actual layer only in the performance pass. It's not in anywhere else. Only in the performance pass in both ECB and PRM. That layer number one, step number one, is to run a com check. Run a com check of your proposed design and make sure that you pass the backstop. So your com check can show minus 15% worse if it's residential, and for other type of buildings, it's minus 7%. Meaning, yes, you can still trade off envelope insulation. It can be worse than the baseline, but the threshold is 15% and 7%. You meet that, then you move on to your modeling, to your actual model to show the detailed whole building model. And how it works is basically compare your proposed design versus a baseline building. The baseline building is defined by the code, by IECC or 90.1. And that has, all the applicable mandatory and prescriptive requirements. And the proposed design is your proposed design, right? If you have your proposed envelope, you have your proposed HVAC, your actual lighting power density, you should probably see about 15 to 20% better than code. If you have PV, simulate your PV. If you don't have PV, don't simulate it. And obviously, you have to have a good geometry. And if you have thermal bridging, derating, make sure you include those. And then you compare, a proposed model against the baseline model. Slide. Oh, that's it. That's all the modeling stuff. Thank you.
Perfect. So commissioning requirements. So everyone's familiar, I'm pretty sure, with commissioning. 2015 IECC had commissioning within there. The big difference now is that there's more stringency about what's required to be commissioned. Uh, if you'll notice there, we do have a line that says below 10,000 square foot gross conditioned area and combined heating and cooling capacity of 960 MBH does not require commissioning. That's for both codes. So what is the commissioning process now look like? It is a third party CX agent that's not associated with design or construction, or an owner qualified employee. That's per ASHRAE. And then IECC uses the terminology registered design professional approved agency. So what's new in the code? Envelope CX is a significant change. So now you'll need full CX for buildings with above 10,000 square feet. Envelope testing is mandatory for smaller buildings, right? So that's along that blower door testing that we discussed. Approved third parties required for testing or design and construction verification. So again, there's a lot more scrutiny on the installation, as there should be, during the construction process. You do have obviously the electrical and renewable portions that are required to be commissioned, and the service water heating water system. A big context here that's also specific to the code is that your CX plan, your commissioning plan, has to be provided before construction begins. Full transparency, we've never had any inspector, ROE, or anybody out there ask for that, but that's how the code reads. So the commissioning process, what is the process? Now, there's a pre-design phase where your OPRs and your basis of design documents are created, and that's usually where your CX plan is also initiated now. That's how the process looks. Then during design phase, you have documentation review, sequence of operation reviews, and CX specifications are developed. Within the construction phase, and this is why it's important to not just bring your commissioning agent at the very end. You want your commissioning agent also to be part of the submittal reviews, performing site observations before saying everything's done and completed and just to come on site. Also, pre-functional checks are developed, and then also issue tracking. Really, what everyone usually associates with commissioning is the step 4 is where it's testing. It's the functional performance testing. That's where you're actually on site doing the testing and identifying deficiencies and putting them into a log. If I had to say, most people are familiar with step 4, but you'll see it's really broadened the whole commissioning process. And lastly, there's a final commissioning report, systems manual, trainings, and seasonal testing. Those are, training and seasonal testing has always been a part of it, but something that's really strong within the code now is systems manual is also a requirement. What's a systems manual? It's a manual that you hand over to your operations team to let them know how they're supposed to operate the building. So what's your role in commissioning, right? So we really touched on this, a lot of it, but the key takeaways: start CX planning before your design begins, not just as a permit submission. Energy compliant path selection affects everything downstream. The thermal bridging and air leakage test requirements should be in your construction documents, what your expectations are to align to the code and with the methodology. Are you going to do a blower door test, or are you doing third-party review? That's very important that that's identified within the specifications or in your construction documents. The CX, you got to remember, is your ally in all this. Engage them early, and they'll help with that design process. And then the documentation, right? It's required for all your construction closeout and all your plans of scheduling. Come on, click. So once again, what's commissioned? A lot of this was in 2015, but there has been elaboration within the building envelope and the renewable energy systems, as those are requirements now, right? So now you've got your mechanical, service water heating, your building envelope, your lighting and electrical power systems, and renewable energy systems. So those are the items that are required to be commissioned as part of ASHRAE 90.1 or 2024 IECC. Often we're asked, what's the commissioning process look like? The great news is ASHRAE has the process well defined, and it's within the table. So table H2 specifically shows you what's required and when they're required. And you'll see there's a pre-design and design phase and construction. So all that's clearly identified within a table, and it's very easy to consume and utilize for your construction documents. Highly recommend you look at this table. Retro commissioning, Cassie asked us to add this specifically. So retro commissioning, I don't know if everyone's familiar with retro commissioning. It's essentially where you go into a building and double check the operations of the building. Retro commissioning is probably the closest thing to free money with a quick ROI. What we always say is that the buildings are typically operated in a fashion that if you have a vehicle and you're running your vehicle for 5 years without an oil change, that's unfortunately is how a lot of buildings are operated out there. So retro commissioning goes and looks back at buildings and looks at the controls, if they're following sequences, what equipment has been modified to bypass schedules. Often there's simultaneous heating and cooling situations occurring. Economizers have been failed or disabled, and that's probably one of your best places bang for your buck for money back on your system. That's why code is requiring it pretty much on most of these new buildings. And then there's also other things like no supply air reset or air systems out of balance. So we wanted to give a typical cost on this is about 20 cents per square foot to do this. And your simple payback is in the 1 to 3 year ROI. The other nice thing is within the Chicagoland area, ComEd also has quite a bit of incentives to perform retro commissioning as well, because ultimately they want to drive down their costs to their utility production plants. Okay. Lastly, we are going to be sending this presentation out. There are 4 slides here. I'm not going to touch on them that summarizes this presentation for you to use in the future. They're your quick reference sheets. So you'll see one for IECC, envelope side, and then a mechanical controls and renewable side, and then same for ASHRAE that will be part of this presentation. So these will be available to everybody afterwards. Okay. We made it. That was a lot of information, everybody. So I appreciate sticking through it. So we want to leave a little bit of time for Q&A.
All right,
Any
thank you.
questions? No, go ahead, Cassie.
Oh, here, I was just going to give a hand. Please feel free, if you're going to ask a question, please raise your hand and we can unmute you or send it in the chat. For some of you, I've sent you some direct messages since I wasn't finding your name. Please be sure to check the chat and reply so we can make sure you get your credits. Otherwise, please feel free to raise your hand or put a message in the chat if you have any questions.
Must have did a pretty good job. No questions. I see your chats. So we answered everything.
We'll give it a minute or two. Perhaps people are typing their stuff up.
Yep.
We have a question from Jason in the chat if you guys can see it. Otherwise, I'm happy to read it to you.
I see it. What has been your enforcement experience with the new envelope requirements? Great question, Jason. Truth be told, and I alluded to this a little bit, is ROEs and AHJs are learning the code still. We haven't had a tremendous amount of AHJs asking for certain documentation. But it is obviously in the best interest of the design professional to perform everything per the letter of the code, right? So we have been providing building pressure envelope testing and providing that information to the ROE or the HJ, but no one's been coming and asking for it, to truth be told.
Oh, that also, you know, Also depending on the kind of documentation you sent to HJs, right? Because if you list those requirements very clearly and tell them how you mitigate, right? So most of our projects, we work very closely with the architects that to do a better detailing on the envelope, and we point those detailing and how the thermal bridging is being mitigated in the energy code document compliance documentation. Saying, hey, um, how is that mitigated? Where can you see that? I think that also helps with the review. And if they don't see a problem, why would they comment? I think that's also very important.
Next one that's in there is, how does stretch code tie into this? Some suburbs are now following stretch code.
The state of Illinois took the stretch code approach. Stretch code came from the East Coast, Massachusetts. And state of Illinois took that approach about a couple of years ago. And it's not, in my opinion, the stretch code Illinois developed is not that stringent. And also, at the same time, I believe Evanston is the only jurisdiction enforces stretch code. There are a couple other jurisdictions that thinking about it. One of the key differences in the stretch code is if you look at the performance paths, most likely you will have to use the performance path. They are using 90.1 2019 PRM, and they changed the criteria to site energy. Why did they do that? Because it's much easier to comply with site energy. So my personal experience, I did not really hear people complaining about complying with the stretch code yet. But we're probably gonna hear more feedback in the next couple of years.
Awesome. There's another one. Can you further describe the difficulty in meeting the efficiency requirements of IECC prescriptive?
Well, so IECC actually got rid of the mandatory. If you look at IECC 2018, you would find like they put mandatory or prescriptive next to the provision. They got rid of that in IECC 2021. Why? Because they moved the mandatory table to the C407 chapter. And the reason why, generally IECC is a lot more difficult to comply is because they made so many more provisions mandatory. If you compare, like, for example, occupy standby, it's prescriptive in 90.1, but it's mandatory in IECC. If you look at the energy recovery requirements, energy recovery is all mandatory in IECC, but energy recovery is prescriptive in 90.1. And also, on-site renewable is a mandatory requirement. It's either you do on-site renewable, like actual PV, or power purchase agreement. There is no way to get out of it. So generally, IECC made more things mandatory and less flexible. That's why generally IECC is more stringent, more little more difficult to comply, I would say.
Next one is, would a similar presentation for residential less than 3 stories be warranted? Karen, I'll take that one. Truth be told, we don't do a lot of residential, but we'll talk to Cassie and see if there's an opportunity there. AJ mentioned, why did the maximum air leakage drop from 0.4 CFM per square foot to 0.35 CFM per square foot? AJ, I think it's just always just trying to be better, right? Trying to make the code more stringent as it continues to grow, right? Honestly, though, with some of the detailing that we've seen out there, we are getting some very good pressure test readings. We often can beat that 0.35 CFM per square foot.
That 0.35 is at 75 Pascal of the building enclosure area, right? Basically, that's your air boundary. Generally, 0.4, 0.35 is a very generous number, in my opinion. So that is not like it's a pressurized number, and it's not super stringent. If you look at other parts of the country, like state of Washington, They made that number, I think it's 0.25 or 0.2-ish. Again, it's not that stringent.
I know we're on time here, Cassie. I'm going to take a couple more. Is that okay?
Yes, please feel free.
Okay, sounds good. Could you describe Stephen asked, could you describe a duct blaster test, the benefits and difficulties in achieving results, examples as outlined in Energy Star requirements? Alan, do you know that one by chance?
The band difficulty achieve results. That is that's more residential, right? I don't really have too much experience in that.
Yeah, unfortunately, I don't either, Stephen. I'm happy to research it, but I don't. I'll be honest, we don't do much of that. John asked, have you tested demising walls in apartment buildings? Have there been problems with this testing? There really are no standards that apply to these partitions, say, compared to exterior walls. John, when you say tested demising walls, what kind of testing are you referring to? If you could put a subsequent comment in there, that'd be great.
That's probably Ehrlich's test because blower door test for apartments is basically testing apartments,
Yep.
not the entire building, right? You basically kind of seal up each apartment. You sample them, typically 20% of those units. Gen Generally, the blower door testing follows ASTM approach, and ASTM is a little blur on specifics. My recommendation is work with the HJ. Have the HJ to tell you, hey, how do they want to see it? Because technically you can, if you have a big enough equipment, you can test the building. Instead of going to all those each apartment. So I would say work with the HJ, ask for specifics, because at the end of the day, HJ, the building officials, give you the certificate of occupancy. They, if they wanted to see certain things, sure.
Yeah, and John, to add to that, since that was a clarification, I think Jason actually just mentioned it there. It doesn't require unit compartmentalized testing. If you were to contract, with a typical pressure building tester, you would still just do the envelope because that's what's required, and then go from there. Right? It's no different than a school with lots of classrooms. You're looking to pressurize the building, the total building area. So if you can get within those square footage thresholds that I mentioned earlier, you're fine, right? And now if you can't because of the size of the building, I just tell you to do third-party review. Okay, just looking through the comments. I think I captured them all. Yes, I think I got them all.
Yep, but from what I'm seeing, I think that's it on the questions. If anyone has any others, we have the information of our presenters here. Thank you so much, George and Alan, for presenting today. It was fascinating to learn about. We'll be wrapping up this recording. Will be available as well as the slides. For those of you who I've reached out to about your registration, please feel free to message me or follow up with AIA if you're not seeing this come up on your credits. Otherwise, thank you very much, everyone, and have a great rest of your day.
Thanks,
Thank you so
everybody.
much.
Thank you.
Thank you.